Okay, this is our classwork on completing the square and quadratic formula. These are just two methods for factoring quadratic expressions and solving quadratic equations. It's really solving quadratic equations and finding the roots of a parabola, so a quadratic function. So just keep that in mind, that complete the square is one method and quadratic formula is another method. And sometimes we just have to look at it and decide what's the best method to use. And sometimes it'll tell you what method to use, and sometimes it'll ask you a question like you see right here in number 1. This classwork, it looks really long, but I just wanted to leave us enough room to work. So I did a PowerPoint and converted it to a PDF. So that's why it looks like this. So I'm going to make this at least 200. Let's see what that looks like. Yeah, that'll work pretty well. So what this question is asking, number 1, if you remember on completing the square, we were always looking at this x term. The x term was the thing that was kind of most important for us to look at, is that x term, which we would call a middle term if it was a trinomial, if it had 3 different terms. But this side of the equation only has 2 terms. So we're always going to look at the x term for figuring out what we need to use for completing the square. So what it's asking us is what quantities should be added to both sides of this equation to complete the square. And if you remember when we did this on the notes, what we did was we took that x term, we divided it by 2, and then whatever we got, we squared it. So negative 8 divided by 2 is negative 4, and negative 4 times itself is 16. So that's the number that we would add to both sides. Now, that's all it's asking us, is what number would we add to both sides? So your answer here would be 16. You don't even have to do any more to it. They're not asking you to solve it. They're just saying, what would we add to both sides to complete the square? And that's how we did that, if you remember from the notes. Okay. This is sort of the same type of problem. It says Jenny is solving the equation, and then she's got her x squared term, and her x term is negative 8x. Well, guess what? That's actually the same. It's the exact same problem. It's just asking you in a word problem, what number should she add to both sides? We just did that one. So again, we look at this term right here. We divide it by 2. Negative 8 divided by 2. And then we square that number. So again, we would add 16 to both sides, and that's the answer there. We're not trying to solve the equation. They're just asking us what number would we add. Okay, and this one says solve by completing the square. So this might have started out, you don't have to write this part, like this. And we might have looked at this and said, okay, can I factor this by just looking at the negative 9? Yeah, we can, but it's asking us to complete the square. So what it wants to see, what they want to see is they want to see our work and see that we know how to complete the square. So if it started out like this, we would add 9 to both sides if it said complete the square, and we would get what they have right here. So again, guess what? We have the same x term again. So they just asked us a while ago, what would we add to both sides to complete the square? Well, we would add 16. So if we add 16 to the 9 and we add 16 to the left side of the equation, adding 16 to the left side of the equation just gives us x squared minus 8x plus 16. Those aren't like terms, so we can't add them together. 9 plus 16, though, we can add to get 25. So then what we do is we find that binomial that, if you remember this, let me use my highlighter instead. This right here is called a perfect square trinomial. And to find the binomial that we want right here, so it's going to be something times itself, something squared. What we do is part of what we did to find the 16, we just take this number right here and we divide it by 2. So negative 8 divided by 2 gives us the number that goes right here, and that's going to be minus 4. So x minus 4 squared equals 25. Now I just solve for x. Well, if you remember, if you're in my Math 2 class, you remember we had some problems like this the other day. X minus 4 squared, I'm going to just rewrite it, make it a little bit easier to see. equals 25. When you have one like this, the first thing you do is take the square root of both sides. So if I take the square root here and I take the square root here, that square root gets rid of your exponent. So I have x minus 4 equals, now the square root of 25 could be positive 5 or it could be negative 5 because negative 5 times itself is also 25. So I'm going to have two answers here. On the positive side, use my highlighter again, I'm going to have a positive side and I'm going to have a negative side. So the positive one, I'm going to rewrite it x minus 4 equals positive 5. And then on the other side, I'm going to write x minus 4 equals negative 5. So I used the positive 5 on the left and the negative 5 on the right, and I just created two different equations. And so if I add 4 over here, I get x equals 9. And then if I add 4 over here, I get x equals negative 1. So I have two answers, 9 and negative 1. And this is what these are. These are the x-intercepts. These are the x-intercepts. So if I graph this, this would be a parabola. Let's see. Its a value is 1, so it opens up. Let's see. Here is, let's say, here's negative 1 right here. Here's my negative 1. And my 9's way over here. So it might look something like, would open up and it would go like that. So the 9 and the negative 1 are my x-intercepts. They're also called roots. They're also called zeros. So a quadratic is always a parabola. All right, moving on. Solve by completing the square. So this time I have a negative 9 that I need to get rid of, not get rid of, but I need to move it over to the other side. So I'm going to add 9 to both sides because I need to only have my x squared term and my x term. So when I add 9 to both sides, I have 3x squared plus 6x equals 9. Okay, the next step in this is to make sure that your x squared term is a 1. Well, it isn't a 1. So is there a way that I can make it a 1? Yeah, I just divide by the coefficient. So divide by 3 here. Well, if I divide by 3 there, I have to divide everything by 3 to keep it still the same equation or an equivalent equation. So then this cancels. So now my x squared coefficient is a 1. This is going to be 2x equals, and then 9 divided by 3 is 3. Okay, so now I can move on from there. Now I need to complete the square. Okay, so look at this term right here. It's a positive 2. Divide 2 divided by 2 equals 1, and then 1 squared equals 1. So I need to add 1 to both sides. Plus 1 plus 1. X squared plus 2x plus 1 is how I have to write that. That right there. They're not like terms, so that's how I have to write it. 3 plus 1 is 4. So now I need to factor the left side. And it's a perfect square trinomial, so I can just divide 2 by 2. That is the number that goes in the parentheses. Positive 1 squared equals 4. Okay, so x plus 1 quantity squared equals 4. Now I just solve for x again. Square root, square root. Square root gets rid of the exponent. X plus 1 equals plus or minus 2. Two different equations. Because I've got the x plus 1, if it just was x equals, I'd just leave it. This is the positive and the negative. Positive side, x plus 1 equals positive 2. X equals 1. Negative side, x plus 1 equals negative 2. X equals negative 3. If I went over and I graphed this, this original equation on Desmos, I would get a parabola with zeros or x-intercepts at 1 and negative 3. Okay, I think there's one more. Yeah, there's one more completing the square, then we're going to look at quadratic formula. Pause your video and see if you can do this one by yourself and then come back. Okay, so I don't know if you're able to get this one, but you actually have to leave this in a radical. So I added 4 to both sides. Well, actually, at first I added 1 to both sides, and then I figured out what I needed to add. I needed to add 4 to both sides, so I got that x squared minus 4x plus 4 equals 5, and then I divided the negative 4x by 2, and it was minus 2, and that was x minus 2 quantity squared equals 5. Okay, so then I took the square root of both sides, and when you take the square root of 5, you don't want a decimal, so you don't want to put that in your calculator. You want to leave it square root of 5. But it's going to be x plus 2 equals plus or minus square root of 5. So x, actually let me do that in green. X minus 2 equals the positive square root of 5, and x minus 2 equals the negative square root of 5. So then I just add 2 to both sides, and I get x equals 2 plus root 5 on this side, and that's all I can do on that. This is an imaginary root, so we actually wouldn't be able to see this. I'll show you what it would look like in just a second. And this one would be x equals 2 minus root 5. So I'm going to pause this and I'll come back. Sorry, I misnamed this. I said imaginary. It's not imaginary. It's irrational. It's an irrational root. But what they do is they show me, I went over and I actually graphed this on Desmos. I happen to have it pulled up on my computer anyway. And so I graphed it, and the x-intercepts are at negative 0.236, and again, that's going to be like a repeating decimal, and 4.236. So if you were to go on your calculator and estimate square root of 5, like if you went and, let's see, oh, I can never remember how to get out of this. Oh yeah, second quit. Okay. If I did second, okay, square root of 5 is about 2.236. Okay, so this would be, if I wanted to estimate this, I could say, okay, this is 2 plus, do the green side, 2 plus 2.236. Well, that would be 4.236. And then this would be 2 minus 2.236. So that would be 0.236. And if I look at Desmos, there it is, negative, whoops. Sorry, that would be negative right there. So negative 0.236 and 4.236, which is what we got here when we estimated it. I would just assume you leave it like this. If you're graphing it and you graph it and you don't complete the square, because this said complete the square. So we need to complete the square and leave it in simplest radical form, not graph it and then put those decimals in there. So if you put decimals in there instead of what I've got in the squares right here, or in a rectangle right here, then I would count it wrong. Even though this is an approximation of the roots or the zeros, I would still count it wrong because you were asked to complete the square. You were asked to solve it by completing the square. Okay, so here's one that I don't really want to mess with trying to complete the square with it, because first of all, my x term is odd, and to divide that thing by 2 and then try to square it would be a pain. Also, I don't want to divide through by 4, so for this one, I would use quadratic formula. Okay, so let's rewrite it and add 9 to both sides. So 4x squared, let's use different colors, plus 13x plus 9 equals 0. So we are going to use quadratic formula for this. Let's review what quadratic formula looks like. There's like these songs that you can memorize that are for quadratic formula. I don't think they work very well. I don't think like little tricks in math work very well. If there's a way I remember something, I'm going to tell you what it is, but I don't like the little songs. So I'm just going to show you the quadratic formula. So quadratic formula is x equals the opposite of b plus or minus square root of b squared minus 4 times a times c, and all of that is over 2 times a. Okay, so that's what it looks like. So we're going to use this formula. We need to identify our a, b, and c terms. So let's do, our a term is in red. A equals 4. So let's talk about where that term is going to go. Let's highlight the A. The A is going to go there and there. All right, the b is in blue. B equals 13. So where's that one going to go? That one's going to go here and here. And then our C term is in green. C equals 9. And I won't do this for every one of them. And that one's going to go there. So just so you know what numbers are going to go where. All right, so let's get started. We're going to write, I'm going to try to write this kind of small right here. X equals, and then I'm going to have a fraction. The opposite of b is the opposite of 13. That is negative 13. I meant to do that blue. Negative 13. So there's my b, but I have to take the opposite of that. And then plus or minus. This is where our two parts come in. There's two answers to this. There's always two answers to a quadratic. Okay, and then b squared, so 13 squared, and we'll figure out what that is in a minute, minus 4 times, all right, a is 4, and c is 9. Okay, so there's those colors there. And then all of that over 2 times 4. Okay, so now I'm just going to use black for the rest of it. X equals, okay, negative 13, we still got that, plus or minus. We got to get what goes under this. 13 squared is 169 minus 4 times 4 times 9, that's 4 times 36. That's 144. And then all of that over 8, okay? So let's figure out what this part is. 169 minus 144 is 25. Well, that makes it a little bit more convenient because I can take the square root of 25. Square root of 25 is 5. So what I did was I took 144 away from 169, and then I took the square root of that, and that was plus or minus 5. So 169 minus 164 is, 144 is 25, and the square root of 25 is 5. So that's where I got that number, and then all of that is over 8. So at this point, I can leave it like this, or I can change it to two different answers. I wouldn't care if you left it like this, but if you want to change it to two different answers, all you do is you take the positive 5. Well, actually, no. Let's do that because we don't have a radical right here. So we need to do two different equations. So we're going to do a positive 5 and a negative 5. So we're going to go back and do x equals negative 13 plus 5 over 8. And then x equals negative 13 minus 5 over 8. All right, so negative 13 plus 5 is negative 8. Negative 8 over 8, x equals negative 1. So that's one of our answers. Negative 13 minus 5, negative 18. Negative 18, divided by 8 is going to be negative 9/4. And we'll leave it like that. We're going to leave it as a fraction. If you graphed it, they would give you the decimal right there, but since you were, well, I guess it would be fine if you put a decimal on that one, but if it's a radical, I don't want you to do the decimal. Okay. Okay, we have two more problems to do. On number 7, it doesn't tell me which method to use. So if it doesn't tell me which method I have to use, then I'm going to look at first and I'm going to say, is there a factor pair for -1 that equals -4? No, there is not. So I can't factor it using that, but I could complete the square because I have an even number here. And if you have an even number there, it's kind of easy to complete the square. So let's add 1 to both sides and rewrite this like this. And then we'll take that middle term, -4 divided by 2, and we'll square that. So that's -2 times -2, which is just 4. So that's going to be, we already did this one. We did one like this, I think. We sure did. Maybe we did it in the notes. Looking to see. There it is right there. We did this one. So since we already did this one, we know the answer, don't we? X squared minus 4x equals 1. Yeah, they just gave us the same one. So all we need to do is just write the answer. So let's just do the answer. The answer is x equals 2 plus root 5, or x equals 2 minus root 5. So again, you could use quadratic formula with this. You could use completing the square. It just depends on, I would usually look at the middle term and see if it's an even number. If it's an even number, you can do the complete the square. Last one. We're going to want to do quadratic formula on this one. So I went ahead and wrote the quadratic formula here. If you want to pause your video and try this one, you can, or you can just work along with me. We need to identify the a, b, and c. So a equals 6. A is our coefficient of our x term. B equals -2, and c equals -3. Okay, let's plug these in. B is -2. I need to take the opposite of that. So the opposite of -2 is 2. X equals 2 plus or minus square root. -2 squared is 4. Minus 4 times a times c. 4 times 6 times -3. And I'll work that out in just a second. And then that's over 2 times a, which is 12. X equals 2 plus or minus, let's work this stuff out under here. 4 times 6, 24 times -3, -72. So minus -72 is plus +72. I think that's right. So that would be 76 right there. Oh, I didn't mean to do that. All over 12. So we have a 76 that we need to simplify. We need to do the simplest radical form. So come over to your calculator, hit y equals, and then put in 76 divided by x. And then hit second graph. And it's going to give you your factor pairs. Okay, so 19 times 4 is 76. So I'm going to go back over here. And over here on the side, I'm going to say, okay, 76, square root of 76 equals square root of 4 times square root of 19. I can take the square root of 4 and rewrite that as 2. So that's how I would simplify that. So moving on with my problem, I've got x equals 2 plus or minus 2 square root 19 over 12. Okay, this is almost done. What you can do though is if you have all three of these numbers right here that can all be divided by the same thing, you can simplify this a little bit more. I'm going to divide all of them by 2. 1 plus or minus square root of 19 divided by 6. And that's it. You can leave it like that. Now that one was kind of hard, but on your test it'll be multiple choice. So you'll at least be able to look and see if your answer is one of the choices. All right, so that's all I'm going to do with this. Quadratic formula is like a last resort. Okay, so if you can't figure out how to factor a trinomial or a quadratic in any other way, then you use quadratic formula. But that it's kind of like the last thing that you would use because it's hard and it's a pain to do, but sometimes it's really the best solution. So, all right, see you guys later.